Hi everyone. So this video, there's two of them I separated. This one is going to be just a quick review of solving equations, and then the next one will be another review of simplifying expressions just by combining like terms and distributing. So the equations I'm looking at in this video, they all come from the book, and so if you open your book and turn it to page 104, that's where I'm getting the examples. So the first couple are just like equations we end up having in class last time. Last class we had a lot of two variable equations, and then we plugged in a replacement value for one thing and we ended up having to solve the equation. So this is just that solving part. Okay, so we're starting off with just a one variable equation. So if I had to solve this, remember solving it is finding the value of the one unknown. Okay, so this one, our unknown, is our x right there. Okay, so we're solving it, we're trying to get it by itself. So we're constantly we're asking ourselves what's being done to x and what can I do to undo it. So if I look at x in here, the first thing being done to the x is it's being multiplied by this -5 right there, and then 7 is being subtracted from it. Okay, so to undo that I start with the opposite order. So I'm going to start first. The first thing I'm going to do is I'm going to add 7 to both sides, and I'm doing it to both because that's the only way we maintain equality, meaning we're not changing our equation, we're just rewriting it. Okay, so here's our equation, and so I'm going to add 7 to both sides. Okay, and the whole idea is that over here -7 plus 7 is 0, and so that's why that cancels each other out. And so on this side I have just -5x left. And then over here, when I do my -27 plus 7, I end up with -20. Okay, so my next step is since in the end I want x equals something, it's being multiplied by -5, so my second step is to divide both sides by that -5. Okay, so when I do that, let me just squeeze this in. I'm going to divide by -5, divide by -5. Don't use a division sign, always use a fraction bar. Now, up here when we did the -7 plus 7 and we crossed it out, that canceled to 0, and it dropped off because anything plus 0 stays the same. Over here, when I'm doing that, it's -5 divided by -5 is a 1. So it cancels to a 1, but 1 times x is x. Okay, so that's how I get my x alone. So they actually cancel to different things when I'm adding, subtracting versus multiplying, dividing. And then I do the arithmetic on the other side and I end up getting a 4. Okay, so the idea is if I were to go back up to the original and put a 4 in right there and did all the math out, I should have a true statement. I should have the same thing on both sides. Okay, so then what we got is the same exact equation pretty much, except we've got decimals in here, but that's not going to change our process at all. Okay, so just like on the last one, I started with the thing that was furthest from the x. So in this one, x is being multiplied by 0.25, and then 14.5 is being subtracted from it. So I'm going to start from the furthest piece from x, and I'm going to move over that 14.5 by adding it. I'm adding it so that these will drop to a 0. If I subtracted it, then I would have more. I'd have -29 on that side. So, okay, so what's left is 0.25 x equals, and over here we end up getting a 24.5. So the main thing to remember on these is to not let the decimal change your process at all. Okay, it doesn't change the problem, it doesn't change the way I do anything. In that last problem we divided out the -5 because that's what x was being multiplied by. So here I'm going to divide out the 0.25. Okay, because that's what x is being multiplied by. So 0.25 times divided by 0.25 is 1, and 1x is just x. Okay, on the other side, you can use a calculator for this. Don't rely too much on it. The main thing to remember is if I'm dividing by something much less than 1, my answer should get a lot bigger. So if you got something less than 24.5, you would know that something is off. Okay, this is actually, dividing by 0.25 is actually the same as timesing by 4. So this ends up coming out to be a 98. Okay, so I don't mind if you use a calculator for that part, but you really have to know if your answer is reasonable. You don't want to let any of the decimals in the beginning change the way you do the problem. if you get overwhelmed with seeing those decimals, write the exact same equation and just write them with whole numbers and ask yourself what would you do then. And then you do go back and do the same thing. So in this one, x is 98. So if I plugged in a 98 for x and did all the arithmetic on the left, I should get a 10. I should get a true statement on both sides. Okay, let's try another. Okay, so this one, same process, but here, so x is being multiplied by 1/5, and then 12 is being added. And 12 is being added, I can tell because, let me just kind of make a mark here. Right here, in front of the 12, there's no sign, so we know that that's a positive 12. It's not because of this plus right here. That really goes with the sign of the 1/5. Okay, so 12 is positive, so I'm going to subtract it over, because then 12 minus 12 is 0, and that's why that drops. And I get 1/5 x equals, and that side is -3. There's a couple ways you might have learned to do this. It's important to remember, let me just write something else over here. This equation that we have there, I could have had the same thing and it could have looked like this. It's the exact same equation, okay? Timesing by 1/5 is the same thing as x over 5. And sometimes that helps people because then, in this one over here that I'm looking at, x is being divided by 5, so our natural thing to do to undo it would be to times by 5 on both sides. Okay, so then 5 divided by 5 is a 1, and that's where I get my plain old x, and on this side I get a -15. Okay, also people, when it's being multiplied by a fraction, a lot of times people remember it as multiplied by its reciprocal. And if you think about the reciprocal of 1/5, it is 5. So I did that as well, but you might have learned it explained differently. In the next problem that we do, we are going to use the reciprocal. But when there's a 1 in the numerator of that fraction, like there is right there, I really just have to multiply by the denominator. Okay, so x equals -15 in that one. If I did a quick check up top, and I plugged it in right there, and I plugged in 1/5 times -15 would be -3. And then if I add that 12, I get 9. I get 9 equals 9, so I know that that's a valid solution. The last one I have out here does have a fraction. Okay, so x is being multiplied by 2/3, and 12 is being subtracted. Okay, so I'll deal to 2/3 once I move into that, but I still have to work on the 12 anyway, so it's a -12 there. So I'm going to add 12 to both sides. So I keep it balanced. This goes to a 0. So I end up having this so far. Okay. Alright, so my next step, if x is being multiplied by 2/3, what I can do in one step is use that reciprocal and multiply by the reciprocal on both sides. And let me show you why this works. It works because if you look at the 2/3 and the 3/2, if I cross cancel, the 2's and the 2's drop to 1, and the 3 and the 3 drop to 1, and 1 times 1 is 1. So that really just leaves me with the x on that side. Okay, and then if I want to, if this makes it easier, I don't really need this here, but if it helps, I can do that. And then I can cross cancel again, so 2 can go to 1 and 12 can go to 6 if I'm reducing by 2. And then I go multiply across and I get 18. So x equals 18. I'm going to go over on the side here and show you one other way that some people do it. Some people learn to do it in 2 steps. They look at it as x is being times by 2 and then divided by 3. So sometimes people first get rid of the 3. I'm running out of a little space here, but they first get rid of the 3, and then they cross cancel those and left with 2x equals 36. And then get rid of the 2 by division. And 2 drops, and I get 18. So I get the same thing. It's up to you. I did it over here in one step, but essentially we're doing the exact same thing. This 3, the 2 3's that I used were the same, and timesing by 3, dividing by 2. In this one, this first one I did it in one step, and the second way I did it in 2 steps. But either way, x equals 18. If I plug in 18 for x and take 2/3 of it and then subtract 12, I would come up here and I would get a true statement. It would work. Okay, so those are 4 examples of the basic solving equations. So you should be able to do that part of your homework, but that one homework is mixed between solving equations and simplifying expressions. So you will want to, if you want to try the solving part first, and then once you get to the simplifying, you can watch the next posted video. And let me know if you have any questions. Just email me.